So two more guys, two more questions. So getting no more than 5 questions right. So first off, again, n is 25. P is still that 0.25. 25 hundredths. So we still have that. So with that, it says getting no more than 5 questions right. So what we're looking for, we say no more than 5. So if we say no more than 5, that means from 0, 1, 2, 3, 4, and 5. So no more than 5, which means we have a min of 0, a max of 5. So when we do our binomial distribution, we're going to put that in the Desmos just like that. So we put 25 in, that's your n, 0.25. Then our min is 0. Oh, sorry. And our max is 5. All right, so put that in the Desmos, and let's go and do that. So again, we have a 25, we have the 0.25, we're going to do 0 here, and we're going to 5. So at least no more than 5 means that. All right, so we have a good chance of this happening. Good, well, not a good chance. It's a chance of it happening. So here, we're going to say that's 0.3783. That's the same thing I got here. Yeah, same thing I got there. All right, so with that being said here, that would be a percent of 37.83%. So again, that's not a big chance of it happening. So yeah, this guy's probably just not going to do well overall. So we'll see. So we have one more thing. All right, so guys, we made it to the end. Made it to the end. It's the last one. So we say, how many questions should you expect to get right? And something should have went off in your head and be like, bing, 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 bing. Oh, woo, woo, woo. All that stuff. Yeah, all that stuff in your head. So you should have seen the word expect. That should have popped up in your head and be like, oh my gosh. Expected value. Is that what we're supposed to do? You're right. Expected value. So that's what we're going to talk about on this one because we're talking about the expected to get right. So with this though, if we were talking about a binomial distribution where there was more than just one outcome, or it had more than one outcome but different probabilities, then expected value will work the way we did it with the table and all the good stuff. But with what we have right here, because it's a binomial distribution, we're going to do it even easier. So with this, since we are dealing with a binomial distribution, we're going to find the expected value by finding the mean of the distribution, the average of the distribution. And just real quick, I'm going to do this off to the side. We have a thing called mu. I'm going to give it a symbol. We're going to talk about more about this when it comes to normal distribution. Let's call it mu. That is the mean of the distribution here. And we're going to talk more about that again when we come into to the next lesson. But to find that mu, that normal distribution, so that the expected value, all we're going to do here is just multiply n times p. So whatever the n is for the problem times the p of the problem. So the n we said was 25, p we said was 0.25. So if we were to multiply those two together, we should get 6.25. And again, what does that mean? That means this student should expect to get 6.25 questions correct. But in real life, guys, you can't have a 0.25 question. And 9 times out of 10, unless somebody's doing something like weird or trying to get extra points or something, that's probably the only way you can get that 0.25. So with this, in real life, this student should expect to get 6 questions right. That's what we should expect. Okay, so cool. Guys, that's it though. That's all we got to do. So if we ever talk about the mean of a normal distribution, a binomial distribution, sorry, we'll go ahead and multiply n times p. That's it, guys. That's all this is. So here we go. Good job. And let's go for it.